Welcome, everyone. Thank you for joining today's webinar, Alarm Management Bootcamp, Practical Deployment. This is kind of the second in our Alarm Management Bootcamp series that we've done with MAVERICK. This is co-hosted by ISA and MAVERICK Technologies. My name is Michaela Cooper, and I am with ISA, and I will be hosting today's webinar. But before we get started, I would like to review a few housekeeping items and let you know how you can participate in today's session. First, questions. Please feel free to submit your questions at any time and submit them to me, Michaela Cooper, via the chat tool box on the right-hand side of the screen. We will have 3 Q&A sessions, including 2 shorter 10-minute Q&As within the presentation, and 1 20 to 30-minute Q&A session at the end to kind of answer any remaining questions. So if we're unable to get to your question during one of the shorter Q&A sessions, we will hold it till the final Q&A. And as I said, please submit the Q&As in the chat toolbox to me, the host, Michaela Cooper. If you are viewing along with others at your site, please designate a scribe to submit your group's questions. Unfortunately, with over 400 pre-registrants, we cannot open the phones for questions. If we do not get a chance to respond to your question, or if you would like to discuss a topic in more detail with Paul, feel free to contact him directly, and his information will be given at the end of the webinar. And second, for those of you who just joined, please make sure that you are on mute. Both your computer and your phone microphones should be on mute. If you would like to see the phone and VoIP connection instructions, please refer to the confirmation email that I sent you today, or go to the top left-hand side of the WebEx screen. You will see a tab labeled Meeting Info. All the connection instructions are included there, including contact information if you are experiencing any technical difficulties. Okay, that takes care of all of our housekeeping items. Let's get started. I'd like for Paul to take it from here and go ahead and introduce himself.
Thank you, Michaela. As Michaela said, I am Paul Berwanger. I am with MAVERICK Technologies, and with them I am a principal alarm management consultant as well as a project manager. Educational background, I got 2 Bachelor of Science degrees, 1 in chemical engineering, 1 in marketing. I've got over 30 years of industry experience, of which 25 years have been in actual plant operations. I have worked in all areas of process control, maintaining DCS systems, installing new ones. I have facilitated numerous alarm management rationalizations, and I'm going to share some of my experiences with you throughout the presentation today. And I do confess I am a former alarm management sinner. With the first systems I configured, I think the operators hated me because all alarms are free and you configure all free alarms. And I've realized that that's not the way to go. But first I'd like to talk about MAVERICK Technologies. MAVERICK was founded in 1999, and we are currently the largest independent system integrator in the United States. We have approximately 700 to 800 engineers on staff, and our focus is automation. We focus on making your process safer and more profitable, and we do this through industrial automation, enterprise integration, and strategic manufacturing solutions. And it's really our responsiveness and results-driven approach and dedication to our client success that has enabled us to have it's a worldwide footprint. There's not many continents we don't work with other than maybe Antarctica. We have completed more than 10,000 successful projects in 45 countries. And throughout the years, MAVERICK has received numerous awards. We've been named to the Inc. 500,000 fastest-growing private companies 5 times. We are the Control Engineering 2011 System Integrator of the Year, as well as the 2012 System Integrator Hall of Fame inductee. And without further ado, it's time to move forward. And so what are you going to talk about today? Okay, well, the bootcamp overview, we're going to start talking about the elements of a good alarm system. And really it starts with developing your alarm philosophy. We're going to discuss obtaining project approvals and how we go about that. We're not going to go into it in a long conversation, but there's certain key things you need to keep in mind for getting project approvals. And then we get into more of the meat of alarm management. We'll talk about assigning team roles and responsibilities, and then the implementation, getting it done. But first, an opening word from our General Patton here. Patton was not known for being a great philosopher, but he did have one philosophy, and that was full steam ahead, no matter the casualties. Alarm management doesn't take that approach. Alarm management is a very disciplined way of working with your control systems. And there's certain key design principles that are really important to keep in mind as we go forward, okay? Alarms. And everything comes down to alarms with alarm management. Alarms must be relevant. They have to be useful to the current operating mode, okay? They have to be understandable. Not understandable to the person who configures the alarm, understandable to the operator who has to deal with the alarm. And it has to clearly identify that something has happened and that an action is required, okay? Alarms need to be timely, and you have to give the operator time to take the proper corrective action. And one of the things that we will talk about and how you can actually modify the time an operator has to respond is by adjusting the set point for a given alarm. All alarms have to be actionable, okay, meaning that there's a very specific thing for the operator to do. And I'm not talking about go make a cup of coffee or anything like that. There's very specific actions that the operator has to take to bring the system back to normal operations. And the alarms have to be properly prioritized, and we'll cover that in some detail as we go forward. But these are the key design principles. All alarm systems need to have these characteristics here, okay? You want to have a minimal number of alarms during normal operation. 1 every 10 minutes is about right. You start going more than that, you're going to start having, the operators will start having problems. And you also want to minimize the number of alarms during an abnormal operation, and it's called an alarm flood. And we'll talk about that here a little bit as we go forward. Alarm priorities are really important because they really help guide an operator's actions during a high alarm activation. And different priority alarms should be discernible, not just visually, but by the sound they make. So an operator has no doubt as to which is the highest priority alarm, which to get the most attention first. And something to keep in mind is the consequence of missing an alarm is another alarm. That second alarm must have a higher priority. So you may have a medium priority for a certain deviation, say, for example, a high temperature, and then you have a high, that will have a higher priority. If they both end up with the same priority, you don't need 2 alarms for them, just 1 alarm. And where practical, we want to have our standard operating procedures tied in to all the alarm points. And this is also part of a great training tool for the operators as they go forward. And here's a real key thing, okay? You want the operators to run the plant and operate by surveillance. You don't want them sitting there reacting to alarms. So I've seen this so many times where operators are just sitting there waiting for the next alarm to come in because they get inundated with them. You want them to operate by surveillance because there's some huge, huge benefits to that as far as improving process optimization. And then the operator has to have clear guidance on what to do, how to act or react to system status alarms. And these need to be different audible indications from your process alarms. So how do we start with this whole process? Well, everything starts with an alarm philosophy. This is a fundamental document. ISA 18.2 does cover this in some detail, but really it starts with some basic definitions and it really extends them operationally, okay? You define what is an alarm. That's the first and foremost. We have to understand that an alarm is a warning that requires an operator action, okay? We talk about alarm priorities and how alarm priorities get assigned. A lot of times alarm priorities become an emotional issue. People think they need to be high priority or urgent or whatever it happens to be. But there's a very disciplined approach to establishing alarm priorities, and we'll be talking about that. We'll talk a little bit about alarm classes. That's not probably the most important thing when it comes to alarm management, but there are alarm classes that are defined within ISA 18.2. But what's really important are the performance metrics. You want to understand what your system's supposed to look like when it's all said and done. If you don't establish metrics up front, you're not going to know whether or not you're going to be successful with your alarm management program. So metrics are absolutely key. You want to understand what your performance limits are. These are limits of operability. These are mechanical limits that you have. And then also the reporting requirements that the ISA 18.2 defines. The philosophy also specifies the life cycle stages, okay, and you can take this right out of ISA 18.2. It's very simple, and it's maintained to ensure consistent alarm management throughout the life cycle. And one of the things to keep in mind, and there's a company I've worked with before putting together alarm philosophy, and it took them over 2 years to do it. An alarm philosophy, while it's a very important document, is not a huge effort. At the end of the day, most alarm philosophies are fairly similar. So don't spend a ton of time on your alarm philosophy because, as I said, it's fairly prescriptive. If you work with somebody who's done this before, they can really help guide you through the process. It doesn't take 2 years. It can actually take a couple of weeks to get a good alarm philosophy put together at your facility, and then you can begin the overall process. First and foremost, though, an alarm system, and this doesn't vary from alarm philosophy to alarm philosophy. Every philosophy needs to define an alarm. And I've not seen any alarm definition that is not exactly like this. An alarm is a warning to the operator that immediate action is required to correct an abnormal condition in the operating unit. Okay, it's a warning, and an operator has to have immediate action. And the action can involve either manipulating the control system to bring a certain parameter back in line, or it could mean initiating some plant procedures, emergency evacuation procedures, something like that. But it's a very specific action, okay? And so that's what an alarm is. But what don't we alarm, okay? Well, and this is something you'll find a lot. There's a lot of alarms that are configured in system, but there's no response required from them from the operator. And as you go through the rationalization process, those things just get moved away. Unit status changes, for example, that do not require an operator attention. I don't know how many times I've seen at facilities where a pump gets turned off. Okay, the pump is supposed to be off now, but they end up getting a low flow alarm. Well, you're supposed to have low flow. You're supposed to have no flow. The pump is off. And so these are things you want to make sure you do not alarm, things that don't require an operator action, okay? The other thing is, too, it's a warning of events which are too fast for the operator to prevent. And so as you go through the prioritization, one of the things you take a look at is time to respond. If something is, doesn't give enough operator enough time to respond, you need to take a closer look so the operator has something to go on to give them a minute, 2 minutes, or whatever to respond. Other things not to alarm, signals which confirm successful operator actions, okay? If I turn off a pump, I don't want an alarm. And you don't want to have duplicate alarms, and so many times I'll see people, they'll set up an alarm on a transmitter, and they'll also set up an alarm, the same alarm on a controller. So when one high temperature comes in, 2 high temperature comes in. You don't want an alarm on that. And last but not least, you definitely do not want to alarm a sleeping lion. Okay, so let's talk about alarm priorities, okay? And in a nutshell, this is something that you use a matrix to define. They should be prioritized that the most important alarms at any given time are the most obvious to the operator. And that kind of goes without saying, okay? But what you want to make sure is that they can distinguish these sound and visually from the other alarms, because this is really what helps the operator deal with multiple alarms at the same time. And alarms are going to be prioritized based on 2 factors, okay? The severity of a consequence, and we'll talk in terms of safety, environmental, and economic terms, and the time available to the operator to make the corrective action. And so in your alarm philosophy, you should have 2 tables in there. One's going to define the consequence rating, the severity. And yours doesn't have to be exactly like this, but this is not a bad starting point. If you just want to copy and paste this out of the webinar, feel free to do it. It's a great starting point. But you start talking about, okay, here we have a consequence, okay, and then we have different levels. We'll have critical, serious, moderate, and minor, 4 different levels. The names you use for them really don't matter, but you need to have these multiple levels. And then you start talking about the people aspect. This is the safety aspect of things, okay? Anytime somebody has a risk of getting hurt, that's automatically going to be your highest priority. Because, typically these would fall into this situation. For example, you get an alarm, a safety shower activation out in the field. Okay, if somebody's using a safety shower, you need to get help to that person out there immediately. So that immediately becomes the highest priority. And with regards to people, those are the only alarms. They're the critical alarms because somebody is in harm's way. As we move to the economic, This is where we start getting, okay, now we have the multiple alarm levels, okay? You can have a damage or financial loss to your facility, okay, of whatever dollar threshold you assign to it. And typically, anytime you trip a plant, it's critical. You want to keep the facility running. The next level under the economic would be a significant production upset or unplanned rate reduction. That would be categorized as serious. If you have a minor production upset, that would be more moderate. And then a minor one would be it's a minor production inconvenience and a lost opportunity, but the dollar value is really pretty low. On the environmental side, okay, you have an uncontrolled or controlled environmental release that exceeds any permit limits. That would be a critical alarm, okay? On a serious side, you're going to have a minor spill or release, and it's in a quantity that affects people only on the site. This is not off-site. If you have a release that goes off-site, that becomes a critical priority. And then moderate would be a local release in minor in quantity that affects only people in a specific unit. It's not site-wide. It's a specific unit. And in minor, there is really going to be no measurable consequences. So that establishes now the ranking for the severity of the consequences. Now we're going to talk about how you allocate an urgency rating to these things, okay? Well, immediate action, immediate operator action, typically is measured in seconds, typically less than 1 minute. And this is something that, operators are required to initiate a remedial action to clear the problem and bring it to a safe state. It has to be done immediately. The next level, typically between 1 and 5 minutes, is what we call the action level of urgency. And once again, the operators are performing an action, but it doesn't have to be as quick as the immediate action. The attention level is 5 minutes to an hour. These tend to be more minor alarms, or it could be a high alarm, whereas a high alarm would be the immediate action. This gives an operator a long time to address whatever abnormal situation has come up. And the notification, this does not have an audible or a flashing thing on the screen. This basically would go to a journal, and the response time here would be measured in hours. So now we've got our consequence rating, we've got our urgency rating, and then from these come out the alarm priority. So you can see this matrix here. Across the top, you've got our severity rating, minor, moderate, serious, critical. And on the left-hand side, you've got the time to respond, notify, attention, action, immediate. And somewhere your alarm you've rationalized will kind of fit into here. Now, this is just a go-by. It doesn't mean you have to use this table, but it's not a bad go-by for assigning alarm priorities. And what this does, it takes the emotion out of things because people become very opinionated about what should be an alarm, what should not be an alarm. And this kind of moves beyond that and allows you to assign priorities based upon engineering discipline and operator response. Now comes the real tedious part of this whole thing. Oh, my God, alarm documentation, right? Nobody wants to spend their career doing reports, okay? So I highly recommend having tools available to generate the reports. But you got to kind of be careful with tools as well. If you have an alarm system that's generating upwards of 100,000 alarms per day and you're going to log all these to a printer, you better plan on having a lot of paper in place because you're going to go through it. That specifically happened to me. I hooked up an alarm. This is probably about 30 years ago. Oh my God, I hooked up one of the old Genicom dot matrix printer to a Bailey-Net 90 system. I had just configured it, got the thing up and running. And, of course, it's the end of the day, 5 o'clock. I turn the thing on, and I come back the next morning to see how many alarms were generated, and the operator wanted to kill me because the thing ran out of paper about 2 o'clock in the morning. This is 5,000 sheets of paper, and there's paper all over the control room just generating the alarms reports. So you got to be careful with that. Use the electronic tools that are available. They'll make your lives a lot easier. Now, here's a key thing, determining alarm set points. And this is the process condition model. This is taken from ISA 18.2. This is one of the levers we have in the set point selection that will give an operator more or less time to respond to things. And so when you're taking a look at systems, especially new systems that you're putting in, okay, and you want to choose a set point, you need to take a look at, okay, what's my normal operating range? And you don't want to alarm in your normal operating range because you'll be alarming all the time. But you do get into the pre-upset area. And that's where you want to have your first level of alarms. You're moving outside of the normal operating range. You're not quite to the upset level, and it's in that range that you want to assign the set point for typically your high or low alarms. Then you move into the upset area, and now your urgency is increased. This is going to be the higher priority alarm. And once again, you've got a process upset. You're going to initiate a high or a low alarm so the operator responds more quickly to get the system back to normal operating. And if you can't do it by that point in time, what ends up happening is that your shutdown system will take over and shut the unit down safely for you. But you use the process condition model. You need to know your normal operating ranges. You need to know how fast a system responds, how fast a temperature can change, and choose your set points accordingly so you give the operator as much time to respond as possible. And there's all types of alarms, and this is something I found kind of humorous. I really felt the guys on the ISA 18.2 committee, they must have had too much coffee that morning because they just defined all kinds of alarms. And we all know you have high alarms, low alarms, but these guys really went overboard. It's probably really nothing you need to remember out of this, just that the guys in the ISA 18.2 kind of get carried away with themselves occasionally. So let's talk about metrics, okay? And this is real important. This needs to be part of your alarm philosophy, okay? What are the metrics? All right, and this is, okay, typically you want 150 alarms per day per console position. 6 alarms per hour, that's about right. 1 alarm per 10 minutes, and this is in normal operating conditions, okay? You want to really engineer the system, though, that when you do have a process upset, you don't get more than 10 alarms in 10 minutes, because if you go beyond that, you have an alarm flood, the system becomes unmanageable. An experienced operator can really handle these things pretty well. They've kind of been through it before, but with some of the newer operators or board operators, they haven't seen a lot of these scenarios come up, and it makes it very, very difficult for them to actually get the thing back to where the system needs to be. So you really want to focus on these metrics and take a look at and work with the operators to make sure that the alarms that are coming in meet these metrics. And this is out of ISA 18.2, and MUA has the same standard, so you really need to take a close look at this. This is kind of standard throughout the industry. When you're developing your alarm philosophy, just kind of copy and paste this in, because this is what everybody has. The other thing the ISA talks about is the alarm priority distribution. And all I have to say about this, realistically, if you follow the rules for prioritization that we talked about, your priority distribution may not match this. If you are working at a facility, for example, that produces poisonous gases, it's going to be, you're going to have more high alarms relative to the low alarms. So let the engineering speak for itself. You don't have to go use this verbatim. The distribution is nice. If you have it come out like this, that's kind of serendipity. But let the engineering speak for itself, because that's what's really important. And typically in your alarm philosophy, you're going to have a table such as this. If you want to copy and paste this one, feel free. But you want to have all the things that go into alarm philosophy metrics in one table that's there for easy reference. And I love the guys on the left there, the metrics. We have no use for feet. Anyway, I digress. But you want to make sure you have these targets there. And there's a couple of other ones that are not listed here you may want to consider. For example, filtering and alarm deadband. Those are two things that, when used judiciously, can help reduce alarms dramatically. And in summarizing, okay, alarm philosophies, okay, this is a typical table of contents right here that goes into an alarm philosophy. We talked about a lot of these things already. If you want a more detailed example, feel free to contact me. I'd be happy to provide you anything, whatever I have available to you. But this is, once again, a typical alarm philosophy table of contents. These things, pretty much at a minimum, need to be addressed. And with that being said, are there any questions right now on alarm philosophy development?
Yes, thank you, Paul. So this is our first Q&A session out of 3. I've received a few questions here, and I encourage you to join the discussion here and continue to submit questions to me via the chat tool, to me, Michaela Cooper. The first question comes from Martin, and he says, you speak of a minimum number of alarms. What is a reasonable high number of alarms per unit of time that will not overwhelm an operator?
Normal, what's considered manageable, is 2 alarms for 10 minutes, but your target really needs to be 1 alarm for every 10 minutes. And that comes out to about 150 alarms per day per console position. And so you really don't want to exceed that. You start exceeding that on a regular basis, and the system becomes unmanageable. And these metrics are consistent with the ISA in 18.2, as well as EMUA 191. This is pretty much an industry standard as far as what is manageable and what is the target.
Okay, great. Next question, Arnold asked, how about plants that are unmanned? Only 1 shift per day max. Surveillance is not an option easily. Seems like the philosophy would be different.
Well, this is a unique situation, and sometimes you have this in offshore platforms or remote gas pumping facilities, things like that, things that are unmanned. And if you have a remote operation station, for example, if you've got something offshore but you're operating it from onshore, if you've got a series of wells, things like that, that are being controlled from a central location, the same rules of thumb apply. If it's a situation where it's only getting active surveillance during a day shift, for example, and after that there is no surveillance, then you have to make sure that the alarms, the alarms that do not shut it down become almost meaningless because there's nobody there to take an action. If I get a high temperature alarm or a high flow alarm that requires an action, but there's nobody there to take an action, it's kind of a meaningless alarm. Now, having said that, you still want to record that information because for troubleshooting purposes, you want to know what shut the facility down during the off hours. So you still want the good alarms. The alarm practices that we talk about still apply, but in this case, if something is unmanned, it's more for troubleshooting and diagnostic purposes than actual operator action type of things. I hope I answered the question, Edwin. That's kind of an unusual one where you have something that's really unmanned.
Great, thanks. Just want to remind everybody that this webinar is being recorded, so it will be available to download in just a few days, and I will send all registrants that information to download the recording. So this is being recorded, and you will get a link to the recording shortly. Okay, the next question comes from Mark, and he says, what priority would you give in an alarm that indicates the shutdown or equipment trip has occurred? In other words, there is a pre-shutdown alarm with a priority and then a shutdown alarm with a priority. How would you assign these priorities? The same?
Yeah, it's interesting. When you shut the plant down, and at the places I've been to, we've had a lot of discussion about this because, oh my gosh, you're shutting the plant down, that should be the highest priority. And what it always ends up being is no priority. You don't have an alarm because there's nothing for the operator to do. The plant's shut down. And trust me, you shut a plant down, everybody's going to know. I mean, it's just the way it is. You're typically going to have a lot of things coming in, a lot of different alarms. So to have a separate plant, you know, if you have a digital or whatever that actually shuts the plant down, that really doesn't need to be alarmed because you kind of know you just shut the plant down. Now, you want the other alarms for troubleshooting purposes, first outs or things like that, so you can diagnose why you shut down. But having an alarm on a point that shuts you down is not necessary because at that point in time, there truly is no operator action other than maybe to initiate some emergency response procedures. But once again, the operator will already know the unit is shut down because of everything else that's screaming at them on their HMI.
Okay, great. Next question comes from Brian. He says, often alarm management philosophies are written prior to DCS selection. Should the philosophy be written before selection or at least tailored after DCS selection?
I'm a strong proponent of having a philosophy before the DCS selection because you don't want to have a DCS that does not support some of the things you want to do. And most, for example, if you really want to get into heavy state-based alarming, things like that, you want to have a DCS that will support that. And so having a philosophy document in place prior to selecting a DCS is a very, very good idea.
Okay, next one. What is a good practice related to the amount of data to perform a benchmark?
It's pretty much, and we're going to talk about this during the bad actor portion of this. Really, it's you want all the alarm data because you want to baseline things, and then you can benchmark from there. And with the tools available, it really becomes very convenient to accumulate large amounts. Now, I'm going to talk about here, when we talk about bad actor, where we did a 5-day survey of a facility that had approximately 350,000 alarms in those 5 days. And so the tools that are out there can really accumulate vast amounts of data, but synthesize it so you can make the appropriate decisions about what is going on. So you want to accumulate, from an alarm data point, everything you possibly can. You don't want to leave things off the table because the tools make it very easy to manipulate large quantities of data.
Okay, next question from Daniel, and he asks, is there a need to differentiate between process alarms, i.e. for FDA compliance, and safety alarms, i.e. for personal safety?
They would, from a prioritization, they would be different alarm classes. You will set up alarm classes at your facility, and the ISA provides some guidance in 18.2 on how to do that. But from a prioritization standpoint, the prioritization would be the same. Now, if you're working at an FDA facility, obviously product quality issues are huge. So your prioritization needs to reflect that. But realistically, when it comes to assigning priorities, you're still going to use the same matrix. Now, the words you have in the matrix for consequence, severity, and things like that may change. But whether it's a safety alarm or an FDA process alarm, you would still use the same matrix. But make sure whatever matrix that is really tailored for your facility. There's no need to differentiate or have two separate ways of prioritizing alarm based upon whether one is safety, one is process, one is FDA related. You still want to have one methodology for prioritizing alarms.
All right, moving right along. We may not be able to get to all these questions in this session, but we have a few minutes left here. For batch systems, audible alarms are used to notify the operator that his input is needed to continue the batch. Should this be handled by a unique sound so that the operator knows that it is related to a batch prompt?
Absolutely. Absolutely, yeah. Batch processes are fairly unique in this regard because, you'll have the process running and you'll go from one recipe step to another. And, yes, you do want to alert the operator, and it needs to be a unique alert letting him know that this sequence is ended, it's time to start the next sequence. So when the operator hears it or sees it, they know it's not a abnormal process alarm. It's just normal sequencing within the batch process. So it's a good idea to have a separate audible sound for it, as well as something separate visually for the operator that they know they need to proceed. And typically speaking, in batch processes, the visual aspect of it, I used to just have a circle, and it would be it would be filled in with color when it's time to move on to the next step, and then it'd be hollow, if you will, while the batch is running. So there's another visual indication that, hey, we're done, time to go on. So good question regarding batches.
Okay, that's going to conclude for this session. I know quite a few of you have submitted questions here, but we'll hold on to those till the final Q&A at the end. But continue to submit questions, and we'll get to them at the next Q&A. Thank you.
All right, moving right along. Okay, we've got our philosophy in place. We got to justify what we're doing. And this is the same slide as previously, but justification is now made infinitely more easy thanks to ISA 18.2. Okay? In the past, okay, how do you justify projects? Okay, well, you have return on investment, necessary replacement, environmental reasons. There's a lot of reasons why projects get justified and the board of directors approves the funding and life goes on. But it's always been a real big challenge for alarm management because you really can't apply ROI. And, loss avoidance is kind of tough to, hey, we didn't blow up the plant this year. Well, yeah, that's great, But you can't quantify that in a CEA or an AFE submittal, right? In the 90s and the 2000s, there were some major incidents, and the industry started taking a more serious look at alarm management. But when it came to justification, you were still facing the same hurdles, okay? ROI, loss avoidance, I don't believe this. Well, that changed, and that changed now with the ISA 18.2 standard, okay? And this is really a big deal because this is something now it's an industry best practice. I refer to it as a standard because it really is a standard. And believe me, our friends from OSHA and these other agencies, they treat it the same way, okay? So ISA 18.2, if you don't have it, you need to get it. It's really a vital and essential next step for alarm management. The guys were working on it for a lot of years before it came out. A lot of good stuff in there. There's some stuff in there that I take exception with. For example, all the different alarm types, and there's another thing here we'll talk about in a little bit. But keep in mind, this alarm management standard tells you what you have to do, okay? It does not tell you how you have to do it. And so that's the how you do things is left to you. And that's why really working with a third party is pretty beneficial, somebody who's been around the block a little bit that can help you with the how. The what is very prescriptive in the ISA 18.2 document, and it talks about, okay, the alarm management life cycle, the things you have to do. It has mandatory and recommended practices and other technical reports that follow up. And one of the questions that come up when you're going to be challenged if you're trying to justify alarm management is does ISA 18.2 apply to you? And as Marv Albert would say, yes, right? I mean, if you have a DCS, SCADA system, PLC, if you're working in petrochemical, chemical, refining, platform, pipelines, power plants, pharmaceuticals, mining and metals, I guess if you're working on planet Earth, it kind of does apply to you. I mean, it's that broad. And the other question that comes up, well, we have an existing system. Aren't we grandfathered in? And the ISA 18.2 specifically states, the practices and procedures of the standard shall be applied to existing systems in a reasonable time as determined by the owner-operator. Now, I don't mean to take exception with the ISA. Sorry, Michaela, but I think that is wrong. Because if something happens and OSHA comes in, the definition of reasonable time will not be left to the owner-operator. It's really going to be what OSHA says it is. And so really the sooner the better. Yeah, you are grandfathered in, but you're only grandfathered in until something happens. If something bad happens, you're kind of not grandfathered in anymore. So there's a sense of urgency to get with the program and have a good alarm management program at your facility. What gives ISA 18.2 its teeth? Why do we really need to do this? Well, it's because of RAGAGEP. RAGAGEP is an acronym for Recognized and Generally Accepted Good Engineering Practice. OSHA has trained their people. The Chemical Safety Board has trained their people. They have this document, and they will cite you during investigations and for enforcement reasons. And so it's no longer a case of there's no teeth behind the program. Now there is, and now you can be cited, and depending upon how grievous the event was, the citations and the enforcement actions can be very, very significant. And so RAGAGEP changes everything because now it truly is a standard recognized by the agencies that can come in and determine whether or not you've met the requirements of alarm management. The other thing that alarm management does, it has a lot of mandatory things. Thou shalt do these things. And I don't know how well you can see what's on the screen here with Charlton Heston, but those aren't the original 10 commandments. I like one of them says here, thou shalt say when you screw up. I think those are pretty good commandments to live by. But some of the shall elements include, okay, you're going to have an alarm philosophy. That's a given. Thou must have it. You have to have alarm system performance monitoring. Thou shalt do a rationalization. You need and you must have a master alarm database. Your operators must be trained. You must test the alarms. And then also you have to have specific HMI requirements, okay? You have to have control of who can suppress alarms, all right? You have to have a provision and therefore alarm shelving, and you have to have specific information about shelved and out-of-service alarms. So ISA 18.2 has a lot of mandatory things that you really have to do. And that's why, I'm not trying to push this on everybody, but I highly recommend you get a copy of 18.2 and really become very familiar with it. 18.2 also introduces a couple of new concepts. We talk about the alarm classification, okay? And it's really to track administrative requirements. Some alarms may require periodic refresher training, others may not. The same is true for either testing, maintenance reporting, things like that. Alarm classification, understand, is not alarm priority or alarm type, okay? It's something different, and it goes into a different bucket. This is a frequency we test these alarms. They go into this bucket. This is for operator training. You have an operator training bucket, so you make sure you're staying with the proper alarm classifications. But here's the neat thing, right? There are no specific classes required and no minimum number of class definitions specified in 18.2. So you kind of don't have to do it, but it's really not a bad idea. The bad idea is under the highly managed alarms, okay? Now, in 18.2, there is no requirement to have any alarms of this class. And if you do have some, then you're opening up a can of worms. There's 17 different explicitly identified ISA 18.2 administrative requirements. Avoid highly managed alarms and developing them, okay? There's no benefit from using this specific classification. Just avoid it. Absolutely avoid it. And that's justifying alarms. It's ISA 18.2 that'll help you do it. RAGAGEP is what OSHA or the Chemical Safety Board or some other agencies will use to cite you for variances. When it comes to grandfathering, yeah, you're grandfathered in until something happens, because then you're not grandfathered in if OSHA comes in and says, aha, you didn't follow this. So keep that in mind when it comes to justification. Now we're going to talk about, okay, we've kind of got this back. We've got our project. We're going to get to justification. We're actually going to do a project. And this alarm management project requires a team. And the team has roles and responsibilities, right? Okay, gang, meet the team. Here we go. I'm just kidding. This is a competition. This isn't Maverick right here. This is our competition. But anyway, within the alarm management world, this is going to be your core team. You're going to have an alarm management champion. You're going to have your alarm rationalization facilitator, who is going to be different from the champion. It's not going to be the same person. You're going to have process operators involved in this. That's an absolute must. You're going to have a process engineer, a process control engineer. Now, there can be multiple, and that's fine, but at a minimum, you're going to have one. You're going to have maintenance representation, and you're going to have somebody from your environmental health, safety, and security department as part of the project team. Well, let's start with the alarm management champion, okay? This is the person that's responsible for the overall execution of the program, okay? This is the person that interfaces with the different departments at a facility to make sure that the team members are made available for the rationalization process, okay? This is also the person that pulls together all the required documentation that you need to perform the rationalization. They maintain the master alarm database. They do participate in the rationalization process, and most importantly, they make sure that the rationalization team has lunch every day. Anyway, but this is a full-time position, and it really is a full-time position on the rationalization team. May not be a full-time position at your facility, but when it comes to rationalization participation, this person is full-time. Now you're going to have your alarm rationalization facilitator, and this is a very key position. This person is responsible for leading the rationalization process. They have to be extremely knowledgeable of the client's alarm philosophy. Right? When I say client, this person needs to be from outside the company, and I'll talk about here in a minute, okay? But this person is going to lead the process, the rationalization process as you're going through, and you're going to ensure cross-functional team participation. Why I say this has to be an outside person, and I've seen this in a lot of rationalizations where I've been asked to come in and re-rationalize things. If you do this with all in-house personnel, what ends up happening more often than not, the dominant personality at that facility takes over the rationalization, and it becomes their rationalization. You want somebody, a third party, to come in there and make sure you have participation from the entire cross-functional team. If you do not have a third party, you'll have the dominant person will be doing 90% of the talking, and the other people just kind of shut down. A third-party facilitator enables everybody and encourages everybody to participate, and that's absolutely key to the overall success because everybody has information that needs to be provided. So I highly recommend you have a third-party rationalization facilitator if you really are serious about alarm management rationalization. Another key here is process operators, and they need to be on the rationalization team full-time. Most important thing, these should be the most experienced operators you can have at the facility. You don't want a junior operator on there because they're just not going to have the background, the knowledge necessary to make the rationalization process successful. And it's kind of difficult because I know a lot of facilities that talk about, okay, we're very lean, we don't have a lot of extra people. And what I've encouraged some of our clients to do, and I've been very successful with this, they'll typically bring in a recent retiree to be on a rationalization team. This way, their current operations don't suffer. They don't have to take a board person away for an extended period of time, and they get the benefit of this person's expertise. Because one of the things as you go through the rationalization process, right, what are we talking about? We're talking about causes of alarms. We're talking about consequence severities and some specific operator actions. What you're doing as you go through that process, you're really recording the tribal knowledge of your facility. And having a senior operator there is very important for that. Because as a lot of facilities are facing, operators, your senior operators are getting very near retirement. You've got a group of younger operators coming in that don't have that level of experience. The information that's recorded during the rationalization process serves as a great training platform for the operators going forward, for the new operators, the ones that, haven't seen these things come up over and over before, whereas an experienced operator knows what they're doing right off the bat when something happens. The new operators will need guidance, and it's the information that's generated through the rationalization process that gives them that guidance. So this is really very, very key. You need to have a senior operator and or operators, and they need to be full-time participants in the rationalization process. The process engineer, obviously represents the engineering interests of the facility. They need to be familiar with all the safe operating limits, the working temperatures, working pressures. They need to be familiar with the PHA contents. That's real important. And they also need to be familiar with all the process P&IDs because you use the P&IDs to document your progress. And the operator or the process engineer needs to be full-time on the rationalization team. Next, you want your process control engineer. And that's a picture of me there. No, it's not. Just kidding. Anyway, but this person represents a process control interest in the rationalization process, okay? A lot of times this is the same person as the alarm management champion, but you really don't want that. You want to have a separate person because you want the alarm management champion to be dedicated to that. And this person needs to understand your control system or systems, especially if there's multiple systems out there. Typically speaking, this is the person that's going to generate the alarm database that you can use for the rationalization, turn that over to the alarm management champion. Very key person to have on your team, and this is a full-time position in the rationalization process. Maintenance representation, you can have multiple people from maintenance depending upon what you're rationalizing at any given point in time. For example, if you're going to start taking a look at compressors, rotating equipment, you want to have your rotating equipment expert in there. This person's going to participate part-time, and it'll be different people depending upon what is being rationalized. And to be most considerate of your time, plan ahead. For example, if you're going to do compressors, do all the compressors at one point in time, have the person, the maintenance expert in there then, and let them go back to their regular job when everything's over. And so, as I said, this is a part-time position, and it'll be multiple people depending upon the type of equipment we're rationalizing at any point in time. Next is your EHSS representative, okay? And every time I try to have this person in there full-time, it always ends up being part-time. But these are the people that really, they represent the environmental health, safety, and security interests in the rationalization process. They are familiar with permit limits. That is very important because when it comes to prioritization, you take a look at permit exceedance and things like that. Very important role to play on this thing on the rationalization team. Okay, we got another little Q&A here. We've covered justifying, alarm management. We've covered the project, the roles and responsibilities of the team. We're going to get into rationalization itself next, but Michaela, I'll let you facilitate the Q&A session here.
Yes, great. I've received a few questions here, and if you have additional questions about this portion of the webinar, please go ahead and submit your questions now to me, Michaela Cooper. To start off, the first question that came in, how much time does a typical cycle take to complete first round of improvement, and some idea on cost estimates?
We're going to talk about things you're going to do to improve the overall cycle. Typically speaking, you can expect to rationalize, 50 tags a day, and there'll be multiple alarm parameters associated with each tag. And so, that's just kind of a rough idea. But the other thing too is that when you're doing this, it's going to vary a lot by type of facility. Now, for example, I went to a terminal facility last year to do a rationalization. They had about 500 tanks sitting out there. And so as opposed to rationalizing each of the 500 tanks, we took a look at the scenarios for tanks. We had tanks that were at atmospheric conditions. We had tanks that were heated, tanks that were cooled. Now we had tanks that had hazardous materials, things that did not have hazardous materials. So what we ended up doing is rationalizing the scenarios, and we essentially did 500 tanks in 2 days. So if you have a lot of duplication, the process goes a lot quicker. If you don't have a lot of duplication, then it's going to be roughly 50 per day, 50 tags per day. And whatever the going rate is, for your internal resources and the going rate for the third-party facilitator that you bring in, you can just kind of multiply it out. And I'd be happy to talk to whoever wants to know offline. I can kind of give you some more rules of thumb as far as how you put together the estimates for this.
Great, thank you. Next question is, when is the right time to carry out an alarm rationalization exercise in a greenfield project?
You want to do it, typically you want the P&IDs to be complete, and you want the system to have been fully HAZOP'd, because that information, you need the P&IDs as documentation, and you want the results of the HAZOP, because as you're going along doing a rationalization, you don't want to do things that are not consistent with the safeguard limits that have been established in the HAZOP. So really, it's when the P&IDs have been finalized and after all the HAZOPs have been completed for a facility, then you want to begin the rationalization process.
Great, thank you. Next question: what are your recommendations to manage a hybrid control room with both alarm panels and DCS? I work on nuclear power plants where there are old alarm panels and new DCSs due to some systems modernizations.
Well, your panel-mounted instruments are going to be there, and that's not going to be changed by the rationalization because everything's pretty much hardwired. And so what you want to do when you're rationalizing the new systems is make sure you're not duplicating the alarms that you currently have on all your panel-mounted instruments. And so because you want to make the systems complementary. You don't want to make the systems overlap each other, and that's really the biggest thing to take a look at. Make sure they're complementary. If an alarm is covered on the panel-mounted things, you don't need to duplicate it in your new DCS. You want to keep them separate.
Okay. Next question. Alarm rationalization necessitates DCS configuration changes. How do you do these changes on a running plant? It might be weeks or months between alarm rationalization, output, and implementation.
you really do want to tighten up that cycle a little bit, and I'll talk about it a little bit more as we get into the rationalization. But depending upon the system or systems you have at your facility, we've been able to really automate the uploading of all the new parameters. That's why the master alarm database is so important. You maintain a master alarm database, you make the changes to that, and it gets uploaded to the new system or your existing system. So the changes kind of go in there in one fell swoop. And that's so it can be painful to make the changes one at a time. I mean, there could be thousands of changes. But by using a master alarm database and some of the tools that are available out there in the marketplace, it can really streamline the implementation side of things. And I'll talk about, with the whole MOC process, I really believe strongly in breaking it down into manageable chunks. I've seen a lot of facilities that they've done a great job of rationalization. They're complete with the rationalization. They generate this massive MOC document with 20, 30,000 changes. Who's going to read it? I mean, if you really want an approver to do their job properly, you need to have more frequent MOCs. And I kind of recommend doing an MOC on a weekly basis, and there's a couple of reasons for that. And I'll really go into more detail on that as we get into the rationalization discussion coming up.
Okay, thank you. Next question. We manufacture modular gas liquefaction plants, including the control system, and sell them to clients. Outside of commissioning and startup, we do not operate these plants. Where, in your opinion, does our responsibility for 18.2 compliance begin and end?
If you're the manufacturer of these systems, I really think 18.2, this is just my opinion, it really begins and ends with the people who buy your facilities, so the people who own and operate it. You're the manufacturer of the facility, but it's up to the people who own and operate it to make sure that they're compliant with ISA 18.2. As a manufacturer, you can provide them guidance, but as far as being responsible for ISA 18.2, I don't see that being your responsibility.
Okay, next question. How does this ISA standard relate to standards on binary logic diagram and Annunciator sequence diagram?
Wow. that kind of caught me off guard there. I'm going to pass on that one. I really don't have an answer for that one right now. But if you could, Michaela, remember that question, and I'll get back to the person separately to give them the proper answer.
Okay. All right. Great. Next question. Should master alarm database be Excel or Access Application, or should the client specify an advanced alarm management system to be purchased and used?
Well, I mean, if you're doing it, you're building your own. Microsoft Access or Excel would be great for it. But a lot of times the tools you have in your facility provide that functionality. And it's really recommended to use those tools. Now, they may interface directly. You may find it more convenient to use Excel or to use Access. And a lot of these tools interface directly, can be mapped into the Excel spreadsheet or the Microsoft Access database. But you want to use your tools because those are the tools that are really going to make it easier to interact with your control system. So when it comes time to do the implementation, the changes are made automatically and not one at a time.
Okay, great. Next question. Should fire and gas alarm systems also be rationalized? Also, we need to include it at the performance statistics. F&G often is a separate system with a dedicated HMI.
Well, I mean, I'm not exactly sure what they mean by a fire and death system. I mean, if the consequence of something is a fire, then obviously if you're working in a refinery, things like that, that's going to, get you right up to the highest priority just based on the consequence severity. Likewise, on something where the potential outcome could be death, my first instinct would just say, don't even worry about rationalizing it. Take a look at what you can do to mitigate that so that's no longer the case. If something is so high risk that you're one alarm away from death, that's still too close to death. Rationalization. I don't think comes into play there. I think taking a look at your administrative systems, your engineering controls, to make sure you do not hurt a person even remotely in that position. If you're relying on an alarm system to keep you from dying, I don't know if I want to work at that facility. You really don't want that. You use engineering controls to make sure those scenarios never, ever come up. And you don't rely on an alarm to keep somebody from dying.
Okay, great. Thank you. All right, well, this concludes this Q&A session. We will have our final Q&A session at the end, so continue to submit your questions, and we will answer them at the end. Paul, you can go ahead and continue on.
All right. Okay, folks, time to get her done. Here we go. And these are the elements of getting it done. The boring stuff, the document preparation. Oh, you poor alarm management champion. This is you. Then we talk about the bad actor analysis. That is super important. Alarm rationalization, management of change, training, and implementation. Okay, so the alarm management champion, you got to go out there and get all this documentation, and this documentation is important. Okay, you've got to have the database. You want the alarm analysis, and we'll talk about that even more when we get to talk about here with bad actors in a minute. You want to have your rationalization software. This is going to be a custom thing you buy from a company out in the marketplace, or it could be an Excel spreadsheet, which is typically what I use when I do rationalization. You want to know what the process history is, okay? You need to have your alarm point data, okay, your current trip points and your priorities. You must have current P&IDs available to you. You typically, when you're doing a rationalization, you'll do it system by system for the most part. There are exceptions to that, but typically system by system. And what you typically do is you highlight the points on the P&ID that you completed, and this way you make sure you're getting everything as you're going along. You need to understand your safe operating limits, your fail-safe safety system. You need that as well. You must have your current PHA. The important thing about the PHA, you want this to be electronically searchable. Okay, so many times we'll get a hard copy of a PHA. It's just a rough scan of what was done before. You want to be able to search it electronically because it just makes the process a lot quicker. If I'm searching for TI 101, I just want to be able to type in TI 101 and look for all occurrences of it in the PHA. I don't want to have to turn page by page by page to find occurrences of that, because when you're doing a rationalization, you do not want to take out an alarm that is listed as a safeguard in a PHA. Okay, other documentation, you want incident reports. You want to know what the cost of downtime is. Okay, if I'm down for an hour, how much does that cost us? Because when it comes to developing the consequence severity, you need that information. Likewise, equipment repair costs. How much does it cost to buy and repair this pump? You want unit run information, and you also want the cause and effect diagrams. And these are things that are all pulled together by the alarm management champion. But before you get into the rationalization, what you really want to take a look at are your bad actors. This is actual data that from a client. There's nothing in here that's going to indicate who the client was, but this is 5 days worth of data. They had almost 350,000 alarms in those 5 days. I've listed the top 10 bad actors in here, and those top 10 bad actors accounted for 72.5% of the alarms. If you take a look at the top 6, and that's almost 58%, they were all bad PVs, okay? And what was interesting, a lot of these were associated with pumps. And the reason that these bad PVs were coming, the pumps were off, they were supposed to be off. There was nothing wrong with the system, except they had the zero set to exactly 0, and they were getting a little chattering, instead of just exactly 4 milliamps, they were going like 4.05, 3.95, As it chattered a little below, just below the 4 milliamps, we got an alarm, bad PV. And so what we did the first day of doing the bad actor analysis, we set the extended low a little bit lower than what that chattering limit was. And with literally in one day, we eliminated 58% of their alarms with a bad actor analysis. So the bad actor analysis is really the first thing you have to do, because there's so much low-hanging fruit, and you need to go after that right away. That's super important. The other thing, too, is when the bad actor analysis, the data you generate, now this particular table, I had every alarm listed, the frequency and hierarchy and so forth and so on. That becomes also a level of prioritization you can use when you start getting into the rationalization. So, for example, now we're getting into the rationalization. This is really the heavy lifting, okay? It's typically weeks of effort, right, per system. I mean, it's your team sitting down, you've got your documentation, and you're scrutinizing each and every point as you go along. It can be very tedious, it can be intense, and the people involved really need to be dedicated to the task, okay? But how do you improve this, okay? Well, many facilities, when they begin alarm rationalization, they figure we're going to rationalize everything. But you really don't have to, because you've got your alarm philosophy, you've got your metrics. We want to have no more than 150 per day, no more than one every 10 minutes. We know what the target is, okay? And now you've got a prioritized list of alarms. You want to basically focus your effort on these alarms, the bad alarms, and go after them. And once you eliminate the alarms to get you within the approved metrics set forth in the alarm philosophy, you've kind of done it. And it may be, you may do half of the overall number of tags in your facility. You may do 3/4. You may do 1/4. But you don't have to do every one. Remember, the purpose here is to make the system manageable. One alarm every 10 minutes. If you achieve that after 2 weeks of rationalization, that is success. And so you really want to have a focused approach to this based on priority, okay? Now, having said that, you may get something that only alarms once a year, but when it alarms that once a year, it shuts the facility down. Yeah, you're going to want to rationalize that to see what you can do to eliminate that. But for the most part, you really want to stay with a prioritized list and taking a look at things. The other things to do to help improve the rationalization process, look for duplication of things. Something very typical comes up, gas detectors, okay? At a given facility, you may have 100, 200, whatever gas detectors. They're all analyzing the same thing. They all have the same parameters. You've rationalized one, you've rationalized them all. So get that out of the way. Look for duplication right off the bat, because that helps accelerate the overall process. One other thing to take a look at here, as I mentioned you rationalize one gas detector, you rationalize them all. Gas detectors are kind of unique in that, and I found this in a couple of facilities, and this is just something to keep in mind. Double check the engineering units that are configured, because I've gone to facilities where, they are analyzing things in parts per million, but some of them have not been configured correctly. Some of them are using percent. And so you want to make sure if you catch something like that, you address it right away. Everything needs to be done on a consistent basis. So double check the engineering units on that. But focusing your efforts here in rationalization, and having that whole list, prioritized list, can really get you to your targets, your metrics, quicker than trying to do the whole thing in one fell swoop. Talk about, what are the objectives of rationalization? And I'm not going to go reading this line item by line, and we've already kind of talked about this, okay? But we want to minimize the number of alarms. We only want to have valid alarms coming in, and we want those valid alarms to be properly prioritized. And you want to make sure, is this alarm valid for all operating states? Okay? That, if not, then you want to start considering state-based alarming as you go forward, okay? Does an alarm exist as a result of a layer protection analysis? Is it required or can be deleted, okay? And so as you go through, you record information, the purpose of the alarm, the hazard it provides a warning of, okay, the safe operating limits, the severity from our consequence matrix. It talks about here how frequently a hazard is likely to occur. I disagree with this. This is an ISA 18.2, and this is something you look at when you're doing a PHA. It really doesn't apply to rationalization. You don't really care about frequency. You do from a prioritization point when you're rationalizing, but you don't record the frequency of the alarm because it doesn't come into play at all with regards to its prioritization. Is an alarm a duplicate? What's the time to respond? You need to have the operator action documented and the consequence if the action is not taken. Now, one of the things when you go through rationalization, you have to understand, too, you don't consider double jeopardy. You assume everything else is working. Double jeopardy is not considered here. So you just take each alarm and the consequence of that alarm not working. Okay, talk about management of change. And really, you can't do the implementation until you've gotten approval to do the implementation, and you get your approval for the whole management of change process. Waiting until you've rationalized 10,000, 20,000 different changes is probably not the best idea. What I've done with clients, we've set up I've got a specific format I use for alarm management when it comes to developing the MOC document. And at the end of the week, I issue that MOC document to my client, and then they can take that on for interim approval. And one of the real benefits of this is that, number one, it becomes much more manageable. Okay, the person reviewing this does not have tens of thousands of things to review, and the way things are grouped together. For example, all the gas detector changes, whatever it happens to be, it makes it easier for the reviewer to come to the decision and say, okay, these are valid. I will approve this MOC and go forward. If you wait to the end, as I said, it becomes unmanageable. But the other thing also, okay, as you do your approvals, let's say on a weekly basis or whatever it happens to be, then you can start doing the incremental implementations, okay? Your alarm management champion can update the master alarm database and then do the implementation. The benefit of this is that you're getting, number one, you're getting the benefits of your rationalization sooner, number one. Number two, now that when you monitor the new system performance, you see how much closer you're getting to your ISA-defined metrics as far as the alarms per day. And so you will know how much longer, pretty much, you have to continue the rationalization process. So this MOC process, by doing it incrementally, ties hand in hand with the more detailed approach, the focused approach to doing rationalization. So you get the benefits earlier, and then you know early on when you've hit the limit. It's okay, now we're consistent with what ISA 18.2 says with regards to one alarm every 10 minutes. Very important process. Do it on a weekly basis. It is not that difficult. Your alarm facilitator, the third party, should be able to generate that document for you pretty quickly because it's kind of part of their database already. Last but not least, and this is actually not last, a couple other things, but training. Operator training is real important. Yes, you're going to have operators on your rationalization team, and that's real important because you want the operators who are on the rationalization team to be included in this training because they can help answer a lot of questions that will come up from an operator's perspective, okay? But before any implementation is done, all the operators have to be changed. Now, you're going to go in there, you're going to change their world. They may have alarms that they've expected to get. No, there were no operator actions, but they just kind of gave the operator a warm and fuzzy. They liked having those alarms. But now that's going to change, and they're going to have a different system to work with. And so they need to be trained as to not just what the changes are, but why the changes came about. And that's why it's really key to have the operators who are on the rationalization team be part of this training program because they can help explain things on an operator basis. You want to let them know what to expect and talk about all the new and modified alarms that the operators are going to have to deal with. Typically speaking, the training programs we put together, it's the typical response from an operator as well. It's about time because you end up making their lives a lot easier. The training typically goes very good, and it's certainly very important, but the operators do really embrace the changes that are going to be going forward because it's going to make their lives a lot easier. Talk about the implementation, okay? This is where you see the fruits of your hard labors, okay? How things are implemented will vary based on your control system and or the software tools you have available to you. really talk to your alarm management facilitator. They can help guide you in the process specific to your facility. If you have the right tools in place, the implementation becomes very easy in that you update the alarm management, the master alarm database, and then it changes are propagated to the control systems automatically. Otherwise, it does become a bit of a manual effort, and that's something that not a lot of fun, not the glamour side of the job. So having tools available are really important. Okay, we've done the rationalization, we've done MOC, we've done the implementation, and everybody is done except the alarm management champion. Because now, as part of the ISA standard, you need to monitor your system performance. And this is typically done on a monthly basis. It's really not that difficult because if you have the right tools available, they'll generate some very clear and simple reports that you can use to monitor this. But the importance of monitoring is that, you spent a lot of time and a lot of sweat equity making system changes, making things better for the operators, for the facility, and for the shareholders of the company. You want to continue to realize those benefits. And if you don't monitor things, things tend to drift. You tend to drift back to what you had before. It's an interesting dynamic. I'm not exactly sure why it always happens, but it does always happen. And so the alarm management champion is going to be responsible for maintaining and monitoring the system as they go forward. And the periodic reports are really, really important. Okay, we talk a lot about ISA 18.2. I really highly recommend you get to know ISA 18.2 because, believe me, all of these guys do, okay? And, we talk about the grandfathering in. You're only grandfathered in until one of these guys show up at your doorstep, and then you're not grandfathered in anymore. So get a copy of ISA 18.2 if you don't already have it. Become very familiar with it. It tells you what you need to do, not how to do it, but it is really a great document, and it really is a game changer in the industry. All right, in conclusion, okay, best-in-class alarm management performance is absolutely achievable. At the clients we've done the rationalization at, it's really been pretty remarkable, the changes we've been able to make, and it's just been great. It's really helped the operators a lot. It's made their lives a lot easier, and it's really improved plant operations. I mean, you're not going to be able to quantify the return on investment with alarm management, but intuitively, people who have been through it realize that it's really there. You want to use ISA 18.2 as your roadmap. It's a great document. I mean, a lot of very, very bright people worked on this one, spent a lot of time, a lot of effort. It's a great, great document. You want to focus on the most important aspects giving you trouble. Goes back to the bad actor analysis. Take a look at that first, and then go down your prioritized list. Work on the systems, but make sure you have a prioritized list going forward. You want to utilize a team approach to the fullest because, operations, engineering, maintenance, HSE, they all have a part to play in this, and they all are valuable contributors. So use your team to the fullest. Don't forget the HMI, okay? And that's the window to your alarm management world. And that's a separate topic. We'll probably do that a webinar on that here a little later, but that's a completely separate topic. But make sure the HMI is consistent with colors, sounds, things like that. And remember, you're not alone. There's a wealth of useful solutions to all of your problems. And don't reinvent the wheel. If you have any questions, I'd be happy to answer more of them as we go forward or offline. But there's a lot of tools and people and methods out there, and there's been hundreds of successful projects. You don't have to reinvent the wheel. There are people out there, such as myself, who are really willing to help, and we've got the practical experience to make it happen. With that being said, Michaela, you're on.
Great. Thank you, Paul. That was fantastic. Before we get into the Q&A session, real quick, just thought I'd let everybody know that Paul will be at ISA Automation Week. So talk to him face-to-face, ask your questions. Automation Week is from the 5th of November to the 7th. And the early bird discount actually ends this Monday. So you can save $150 if you register within the next few days. So keep that in mind. And that's isaautomationweek.org.
And if you're looking for me, you're not going to miss me. I'm about 7 feet tall and 380 pounds. So you're not going to miss me.
Okay, so first question from Todd. With a goal of 150 alarms per day per operator, what's the best way to manage who handles which alarms in a multi-operator situation?
Oh, you really want to take a look at console loading. That's really it's an interesting topic, and actually I've just kind of gone through that at a facility. You want to make sure you don't want to split responsibilities for units between different operators. In a given unit, one operator needs to have full responsibility for that. And I've seen, because there's so much integration with a lot of these facilities, sometimes it's a challenge to do. But to the greatest extent possible, you want one operator responsible for one particular area of that facility. And you don't want to have multiple operators being responsible for acknowledging the same alarm, because what ends up happening is one will assume, well, operator A is going to acknowledge it, operator B, will assume, or operator will assume B is operating, acknowledging, and vice versa. So you want to have that alarm show up really just to one operator, and so you don't have any confusion as to whose responsibility it is to acknowledge and address that alarm.
Okay, great, thank you. Our next question is, our process engineers insist on using the alarm system for process warnings. Any suggestions on how to rein this in?
Yeah, bring me in there. I'll strangle them. No, it's not a process warning. I'm sorry. And that's why when you develop the philosophy, part of the whole philosophy thing is that it gets rolled out to people and people understand it. And once again, this is why you want a third-party facilitator, because I have ran into this time and again. You will have a rationalization where, and I'm not trying to pick on process engineers. I used to be a process engineer. No, it is not a warning for them. This alarm system is for the operators, for operating that facility. It is not for process engineering. And so you want the facilitator to kind of really draw that line. And we call that in the alarm philosophy, but it is not the process engineer using the system for their warnings. This is an operations and operator-centric system.
Great, thanks. And now moving back to a few of the questions we weren't able to get to in the beginning. First one is, can you name a few tools that are offered by Maverick or other suppliers as a product?
Oh boy, have that person send me an email offline. I don't want to. I'm been asked not to turn this into a big sales pitch for either Maverick or other companies. So, but if the person wants to contact me offline, my email address is on the screen. I'd be happy to discuss that with them.
Okay, great. The next question is, what is your experience about having different audible alarms? Is it really useful, or the visual identification enough?
Typically, my experience has been the visual identification is enough. You certainly want the highest priority to have a very unique and kind of loud, so if the operator is not in front of the console at any given time, it immediately gets their attention. The lower priority ones could be much more subdued. But really, if you're sitting in front of the screen, visually, it's the visualization that's the most important. If for some reason you stepped away from it a little bit, obviously it's the audible, and then you really want to have the highest priority alarm. I don't want to say screaming at it, but really make sure it gets their attention no matter where they are within the control room environment.
Great. Next question. Should an alarm philosophy document include temporary realistic goals for performance, or only the number suggested by the standard?
No, I mean, you really just want to have what's specified in there by the standard, because temporary by its very nature, this is a permanent document. Your philosophy is a permanent document. There's really no temporary nature to it, and so I would stay with the 150 a day, one every 10 minutes, an hour metrics for alarm frequency.
Next question. How do you distinguish if an alert overlaps an alarm?
That's done during the rationalization process. You take a look at the different points. I mean, if you take a look at what happens at with each tag, and if you have an alert and an alarm on the same point, you basically you don't need both. Now it can be an alert or it can be an alarm, but it's not both, and you do that during the rationalization process. A lot of times it'll come up. You'll have a low something or whatever configured as an alarm. And on the digital side, you'll have a switch out there configured as an alert for the same thing. One of them has to go. You only need one. And then you determine at that point in time, the one you keep isn't an alert or isn't an alarm, and that gets rationalized.
So this next question asks, does an alert make a noise?
You don't want it to. Typically, if you don't require an operator action on something, it's not an alarm, right? And so you don't want it to make a noise. You want it to be just kind of go to a journal and let it be there. Now, having said it, this goes back to the batch question. Yeah, you will have alerts, for certain situations that come up, and this is on a case-by-case basis. But typically, alerts are not audible. You just want them going to a journal. If there's a compelling reason that you want it to, have an audible sound, that's really, and there are reasons that do come up. It's on a case-by-case basis. But you want to be very judicious in how you assign that, because it may be the case where, okay, we've allowed one, now the floodgates are open, and we'll have 100 more alerts or whatever it happens to be. So you need to be very judicious in the selection of what an alert does. Typically speaking, they'll just be journaled. There'll be an electronic record of it, and there won't be anything visual or audible for it, other than maybe if you go to a summary, an alarm summary page. But once again, it's going to be on a case-by-case basis, but you need to be very judicious, because you don't want to, kind of game the system and sneak things in there that truly aren't alarms, but on the screen and everything else, they behave as if they were. You don't want that happening.
Right. Next question. It seems it would be difficult to hit your alarm rate target straight out of the gate after implementing an alarm philosophy. Is it typically a process of reviewing and revising to arrive at the desired rate of incoming alarms?
Well, typically, after the alarm philosophy, you haven't done anything yet. You've just established the framework for going forward. And so you'll start seeing benefits first after you've done the bad actor analysis and have done the implementation on that. You'll see immediate benefits with that. And then after the rationalization, you'll see benefits as well. And so developing the alarm philosophy just tells you what good looks like, how you've kind of defined what success will be. And then it's really after the bad actor analysis and then after during the alarm management process that you actually get benefits, and you can see how well the system performs compared to what we've established as success in the alarm philosophy.
Okay, next. We add low and high alarm limit to pre-warn the operator, and high and low alarm to cause a trip from the shutdown system. The operator has no time for action for this. So do you think it'd be a good practice to add another in-between alarm to give operator more time to take some action?
That would depend on the priority. Say, let's just use the high alarm. You alarm on the high. If the priority is already your highest priority, you do not have a higher priority than that, then you don't need another alarm. If the high alarm is, say, for example, a medium priority, then you could configure an alarm of higher priority to that. Obviously, less operator time to respond. But really, you have to take a look at realistically, what is the operator time to respond? You've got the high alarm for the operator to respond, and then you've got high that shuts you down. If the operator to respond interval between a high and a high is 1 minute, then you don't really need another alarm because it's going to be too fast for them to respond. And then once again, also going back, if the high alarm is already configured at your highest priority, then you don't need another alarm as well. It's only if there's time for an operator to respond in that interval between the high and what you're calling the trip point. If you can get another meaningful alarm in there from an operator time to respond perspective, then it makes sense to configure it. If not, and it all comes down to operator time to respond. If they don't have enough time to respond to the next alarm, you really it should not be configured.
All right, next question. The alarm distribution numbers mentioned, are they for all the alarms configured in the system, or is the distribution for the alarms going to the operator based on alarm history?
It's the all the alarms in the system, how you configure things, not just the alarms that go to the operator. Now, having said that, it tends to be kind of the same in practical. I mean, with the distribution. But once again, don't get hung up on the distribution. If you properly prioritize these alarms during the rationalization, just let the engineering speak for itself. You may have a distribution that looks different than that. And I've been at a couple of facilities because of the nature of their processes that look significantly different than that, but it was the correct distribution for that facility. And we were all agreed on that because of the highly hazardous nature of some of the materials they were dealing with.
All right, the next question is, how do you differentiate too many alarms from too many processes monitored by one operator?
Can you repeat that, Michaela? What's that?
How do you differentiate too many alarms from too many processes monitored by one operator?
If a lot of times, okay, this is something to take a look at, the whole rationalization process as well. Take a look at the console loading. And I think what this question is asking, we may have a system where it makes sense to split this operator position into 2 positions or 3 positions, because from an operational standpoint, that makes sense. And so you do want to take a look at that. So you may have somebody who's getting an excessive number of alarms, but it's really due to the fact that you've got this person responsible for too large an area. And rationalization is not going to get you there. I mean, one of the worst things you want to have happen is you go and rationalize something and you have the same number of alarms, right? Because all the alarms are valid. And so that's when you really take a look at it. It makes sense to split the consoles. I still say, you do want to go through the rationalization process, and if that doesn't get you to where you need to be, take a look at splitting the consoles. A lot of times that does happen. You overload an operator with too many unit responsibilities, and you can't reduce the number of alarms without compromising the system itself. And so that's the balancing act. But take a look at splitting the consoles.
Right. We just got 2 questions left here. Would you send an alarm directly to the maintenance crew?
That would not be categorized as an alarm. That would be an alert, and you can direct it to them. If you have a separate maintenance workstation, you can do that. It's not an alarm. It's not something that needs to be visible to the operator because there's nothing for them to do, assuming you're sending it directly to maintenance. Although a lot of alarms like that that have come in that are more maintenance involved, they do go to the operator, and their operator action is to contact maintenance and get them involved. So it can be either or, however you want to do it. You can have the operator contact maintenance, or you can route something directly to maintenance.
All right, and the final question, what are your thoughts on alarm suppression and alarm shelving? Good or bad?
I think there's a place for it, but it needs to be used judiciously. And the shelving and suppression, you don't want to shelve or suppress things that are really valid alarms, but you keep getting these alarms. Number one, either set point's not set properly. Take a look at the set point. It doesn't need to be set properly, number one. Or you've got what happens a lot. You've got something that's been a piece of equipment or a transmitter that hasn't worked for 6 months, and it's been shelved for that period of time. Well, if something's been shelved for 6 months, chances are you don't need it as an alarm. Just take it out of the system. I mean, if you live without it for 6 months and you hadn't thought it important enough to fix, just take it out of the system. It's no longer an alarm, so you don't have to worry about it.
Wonderful. Thank you so much. Thank you, Paul, for your participation here and attendees as well. These have been some great questions. We, of course, will be sending you a link to this recording in a few days, and feel free to share it with any of your employees or colleagues. So we hope you got some wonderful information out of this, and thank you for attending, and we hope we can see you again in one of our future webinars.
Thank you all for attending.
And have a good day.